You can define acids looking at how many hydrogen ions they can transfer during the reaction, how many hydrogen ions they can donate. So you can talk about mono, di, tri, polyprotic acids. A monoprotic acid only has one hydrogen ion, so it's only able to transfer one hydrogen ion per molecule during an acid-base reaction. An example of a monoprotic acid would be, for example, hydrochloric acid. So we have the compound HCl, we make it react with water. And the compound HCl donates one hydrogen ion with H plus to the molecule of water. And so you only have the chlorine behind, but not the chlorine, the chloride anion. It has kept the electrons from the bond. And the hydrogen ion has been transferred to the water to form the compound, the cation H3O plus. A diprotic acid can transfer 2 hydrogen ions per molecule. So in the case of the hydrochloric acid, the chloride anion cannot react any longer because it doesn't have more hydrogen ions. So there's no more hydrogen ions to donate. If you have an acid like, for example, carbonic acid, H2CO3, then you have more than one hydrogen ion. So potentially more than one hydrogen ion can be donated when an acid-base reaction. And you always do it one at a time. So one hydrogen ion transfer per reaction. So let's have a look at the first reaction. You would have the compound H2CO3 donates one hydrogen ion to the water. And I'm going to start from the water this time because it's the easiest one. So you make one H3O plus, one hydrogen ion, hydronium ion, proton. What do you have left behind? Well, if you have donated one H plus, if the carbonic acid has donated one H plus, what you have behind is the other hydrogen, the entity CO3, carbonate, and a negative charge. And the negative charge are the electrons that the hydrogen left behind when it left the molecule. In the case of the chloride, there were no more hydrogen ions, so the reaction stopped there. What would happen in this case? Well, you have another hydrogen ion, so you could see another reaction with another molecule of water. So if your compound anion HCO3 minus hydrogen carbonate anion reacts with another molecule of water, not the previous one that has already reacted, another molecule of water, then again the H3O minus can transfer one hydrogen ion to the water, and you form the cation H3O plus. And what do you have behind? Well, you end up with the compound, the fragment, the cation CO3, no more hydrogens. You have a negative charge that you had from before, and you have an extra one from the second anion, the second hydrogen leaving the molecule. So you form the anion carbonate. And now the reaction stops because the anion carbonate does not have more hydrogens to donate. If you have a tripotric acid, 3 hydrogens, potentially you will have 3 reactions that might be more or less difficult. We'll see that the more hydrogen ions you try to liberate, the more difficult the reaction becomes. But you could transfer 3 hydrogen ions per molecule. More than 3, or some organic acids have 4 or more hydrogens that can potentially be donated. We call them polyprotic acids. So I'm going to ask you to stop the video now and have a go at this exercise. This is the compound phosphoric acid, the acid phosphoric acid, and well, it has 3 hydrogens, so can behave as a tripotric acid. It has 3 hydrogen ions that can be donated. I'm going to ask you to stop the video and write down the 3 equations that would show how the phosphoric acid donates the 3 hydrogen ions, one by one, to 3 different molecules of water. So stop the video now, please. I hope you had a go at the exercise and stop the video. So how would I do this? Okay, well, let's go for the first one. Phosphoric acid is an acid and it's going to donate 1 hydrogen ion. Let's write here to remember how it looks like, to a molecule of water. So if the molecule of water accepts that hydrogen ions, how it will become? Well, it will become H3O plus. And now what do I have behind? Well, I'm having H2 because the third hydrogen ion has already left the molecule, PO4. And the hydrogen went away as an H+. It left the electron pair behind. So you have a negative charge from the electron that the hydrogen has left behind that is now under the influence of the phosphorus and the oxygen. And that an ion you have formed is called dihydrogen phosphate. You still have hydrogens in your structure. This dihydrogen phosphate still has hydrogens, so it can react with another molecule of water to donate more hydrogen ions. So you can see I go one at a time, not the three at the same time. No, one at a time, because each hydrogen ion goes to a different molecule of water to form H3O plus, the hydronium ion. So I've got another molecule of water. And again, the hydrogen from the dihydrogen phosphate gets donated as an H plus to the water that accepts it, and is H3O plus. And so you have formed another molecule of H3O plus, another cation of H3O plus. What you have left? Well, you have still one hydrogen and the PO4 that hasn't changed. You had one negative charge from before and another negative charge from another electron that is left behind by another hydrogen ion. So that's where you get two negative charges. And that anion is called hydrogen phosphate. And the reaction can continue because you still have hydrogens in your structure, so you can still create another reaction. So the anion hydrogen phosphate reacts with another molecule of water, a different one. It's always a different molecule of water because when it has reacted to form H3O plus, that's it. That's the end of the journey for that molecule. With another molecule of water, it accepts the hydrogen ion, so it becomes positively charged, and with another hydrogen, H3O plus, the hydronium ion. And what do you have left behind? Well, you have the PO4 minus, that hasn't changed. You have two negative charges from before that you already had in your structure, plus one from the electron that the hydrogen left behind, this third hydrogen left behind when it left. So now you have three negative charges, and that is the phosphate anion. So as you can see, is one hydrogen ion at a time to a different water molecule, because the compound, once you have formed the cation H3O plus, the reaction stops for that molecule of water. It cannot accept more hydrogen ions. The structure is H3O plus, and that's it. But what you have is more molecules of water in the structure, more molecules of water in solution, and they can continue accepting hydrogen ions as long as the acid can donate them.